All right, welcome to lesson 13.2, and this lesson is called Finding Outcomes, and you need to get your math journal so that we can write down some notes about finding outcomes. Now, in lesson 13.1, we identified outcomes, different kinds of outcomes, and so what we're going to do in lesson 13.2 is we're going to use diagrams and tables and lists to find the outcomes. So with the first example we're going to use of, or an example of something we can use to find outcomes is a tree diagram. We're going to use a tree diagram to find outcomes. And let's use an example of let's say you're going to a restaurant and you are given, or a deli, and you are given 3 different choices of different kinds of sandwiches you can order. So we're going to say your choices are ham, meatloaf, we got these ideas from our class today, turkey as possible meat choices for your sandwich. And on that sandwich, we're going to pick what kind of bread we want. We're going to pick wheat, white, and Texas toast as different bread options for our sandwich. Now, with our sandwich on this one, here's how a tree diagram works. And you can do these either horizontally across, or you can do them vertically down, but the tree needs to look like something like this. So you start with a ham choice, and with ham you can choose white bread, you can choose wheat bread, you can choose Texas toast bread. We can have another choice we have is meatloaf, and we have, again, our choice is white and wheat and Texas toast. And the third kind of meat choice that we get here is turkey, and our choices were white, wheat, and Texas toast. And so using the tree diagram, we can show you, it shows different combinations that you can make. So we can have 3 different combinations with ham, we can have 3 different combinations with meatloaf, and we can have 3 different combinations with turkey. And so what that amounts to is that gives us a total of 9 choices. So again, this is an example of using a tree diagram to find our outcomes, or list our outcomes. Now, sometimes we can use combinations, and so finding combinations is another way to find possible outcomes. So combinations would be something like this. Let's say that you have, we're going to have a build your own sundae, ice cream sundae. And on your ice cream sundae, you can have, so we're going to list this ice cream sundae. And just take and make this as your example. We're going to make a table for this, and make our table just kind of draw it like this. And we're going to say we're going to have 4 different choices of ice cream toppings. So we're going to just have vanilla ice cream, but we're going to have different kinds of toppings. And our toppings, we're going to say, we had this example in class today. You could put bananas on your ice cream topping. You could put some kind of crumble cookies on your ice cream sundae. You could use hot fudge. And someone else suggested M&Ms, which for a good topping choice. So those are all possible topping choices, and you get to pick 2. So in this case, this combination, you get to pick 2 different toppings. So we want to see, okay, what are all the different combinations that you can form given 4 choices and 2 different toppings. So you could have a banana and cookie topping, you could have a banana and a hot fudge topping, you could have a banana and an M&M topping. Then a different combination, we're going to extend this down just a little bit. You could have, again, you only get to pick 2 in this example. You could have cookies and hot fudge, you could have cookie and M&M, and then you could have hot fudge and M&Ms. So these are all of your choices So there are 1, 2, 3, 4, 5, 6 choices. So 6 choices. Now sometimes, in this case, the order doesn't really matter. But sometimes the order does matter when we are making different combinations. So an example, I'm going to turn the page right now. A combination where the order matters is called a permutation. So we're going to have you write that down. Permutation. A permutation is, again, an example of a combination where the order matters. Okay, so the order permutation is equal to make sure the order matters. So we're going to use an example. Let's say that we use this example in class today. We have Malia and Dominic and Allie and Braxton. And we want to line them up to use the computers. And we're going to make a list of who gets to use the computers first. So our different kinds of orders that we could use are, well, there's different combinations where Malia can be first. So combinations where Malia is first, we could have Malia, Dominic, Allie, and Braxton. We could have Malia, Allie, Braxton, Dominic. We could have, and write these down as we go along here. We have Malia, Dominic, Braxton, Allie. We could have Malia, Braxton, Allie, Dominic. We could have Malia, Allie, Dominic, Braxton. Now those are all the combinations that we can do where Malia is in the lead, or she is the leader. Now we're going to, let's do another example where we have Allie as the leader. So we have Allie, then we could have Braxton, Dominic, Malia. We could have Allie, Braxton, Malia, Dominic. We could have Allie, Dominic, Malia, Braxton. We could have Allie, Dominic, Braxton, Malia. We could have Allie, Malia, Braxton, Dominic, and we could have Allie, Malia, Dominic, Braxton. And I think I forgot one over in this other list over here. So let me double check here. Yeah, I did. I forgot one over here. I forgot Malia, Braxton, Dominic, Allie. There should be 6. Okay? So these are all examples of permutations where we are lining everyone up, but the order matters. In this case, we wanted to make it so that Malia got a chance to be first. In this example, Allie got a chance to be first. And we would keep on doing this so that Dominic and Braxton also got to be first. So this is an example again of a permutation. Now our assignment today is going to be on page 638, and again this is lesson 13-2, and you're going to get your assignment in class.